friends, welcome to another video in this channel. So today exactly what we are going to discuss is that we are going to perform some vector search. We'll create our vector TB in Google BigQuery, and the architecture that we are going to perform today, let me show you what exactly we are going to achieve. So we'll be keeping our files, means the file that we want to perform our vector query and embed that thing and push it to the vector database, that should be coming from from GCP buckets. Okay, so all files will be in the GCP buckets, and thereafter let's say this is our BigQuery, Google BigQuery. Okay, let me give the name. So let's say this is the BigQuery and this is our application code base. Okay, our application, our app. Okay, the primary objective is we'll take the data from this particular GCP bucket. Our app will take the data. Okay, thereafter it will embed the data and create one particular data set and table in Google BigQuery over here and push it, the embedded data, over in this particular BigQuery dataset table. Okay, now after that we'll perform as an end user. Okay, we'll perform one kind of vector search to this particular vector database and we'll get the result back. So today we'll be covering this particular video. Later on, in the next part of this particular video, what will happen that once this particular vector database, we pass our query and get our search result, semantic search result back, we'll be sending that particular search result to large language model over here. Let's say it is our LLM, and we'll get not only the RAG search result, also we'll get, as an end user, our objective is to get the summarization back from the LLM. Okay, so that is our infrastructure that we are going to create in phase 1 and phase 2. So phase 1 we'll be only working on doing the RAG search over here, and in phase 2 we'll be working with the LLM to get the summarization of the RAG back to the user. Now let's jump into the code. So I will share this code, this particular code file or my work file to the GitHub, and I will give the link also in the video description of this particular video. So first thing first, as is shown on our architecture, that this is our target GCP bucket where all our source documentation is present. Okay, so let me show you that first. Let me bring this thing to you. Okay, now this is our Google bucket. HDRG Lite source doc. What it contains? It contains few documentation text file on Light and person like Maxwell, SN Bose, Einstein. So these are 7 documentation over here, very small document, all are TXT file. Okay, now our objective is to get the data from here as is shown in our architecture. Okay, by our application, and do the embedding and push it back to the BigQuery where we will store our data as a vector database. Okay, now we'll be using this particular BigQuery. As you see, there is no dataset available right now and no table also. Of course, there is no dataset. So first thing first, I will read the file from the GCP bucket. Okay, for that particular activity you need to install couple of libraries over here. So this is the library that we are targeting: Lightning Google Community GCS. Okay, and unstructured, because today we are dealing with only the text file, but tomorrow it is possible that we are dealing with other unstructured document like the PDF or PPT presentation. So obviously at that point of time you'll be needing this particular library called unstructured. So you have more, I have put it all the links as in all the video. I try to give you more link to read on. Okay, so in the source code, in the node, you will have this particular link. You can go over there and read more on it. Now, so let us execute this particular installation. First, let us load our libs, install and load our libs, of course. So obviously, I have already run it in this particular virtual environment of Python, so it will not going to install. Okay, for you it is should going to install all the things over here. Okay, now coming to this particular code base over here, let me just make it a big in size so that you can understood properly. Okay, now you see that this is our target Google bucket over here, and we have all the files over here. Okay, so the purpose is that we want to read these files and take the content first, right? So for that particular activity, you need to take one particular library that is called GCS Directory Loader. It is available under the launching Google community. Okay, now once the library has been imported, you need to call and pass the project name over here, the target project or the GCP where your bucket is situated right now, and give it the bucket name over here. So these two parameters are being expected when you create the this particular call this particular constructor and create a class out of it. Okay, so for me this is my test project, and as I shown you already, this is my target bucket name. Okay, so I'll be putting it over here, and a simple method called load, it will load all the content on this particular bucket. So this is a simple method loader.load. Okay, and what it actually give you written, it's a list of document. I will show it to you. Okay, let me first run this particular code. Okay, it will take a few seconds of time as your document go large, and you will have significant time to read it. So just you have to wait patient, let it complete the step first. So it is now trying to read all the document from here one by one. So as you see, while it is reading, okay, so it is actually give you the return back as list of document. Done. So it took away almost 47 seconds around. Okay, and read all the documents from the respective Google storage bucket. So I'm dealing with, again I'm repeating to you, I'm dealing with right now in this particular video with the TXT file, but I will encourage you to the same activity with the PDF and PPT. And in the upcoming video, obviously my asset means today my asset is only the TXT file. Tomorrow it will be PDF and PPT. I will show you that also, but I will strongly encourage you to explore that path also. Now one that has been read, okay, it is actually returning you the list of document. So document is one particular class available in launching. Okay, now as you see, I have printed the LST document over here, and you see the document is containing this particular data. Okay, so let me copy it and paste it to a notepad so that you can have a better view of that. Okay, now I have copied the thing and I pasted over here. Okay, so just concentrate on one particular document. So it's all the document, all the 7 document that we have in our Google bucket right now. Okay, so it say this is the first document over here. Okay, and you see it has a property page content. So page content actually containing all the data that had been present on the particular document up to this. Okay, now metadata is the source from where it read out the data. Clear? So it has two property. It has a property called metadata and it has a property called page content. Page content contain all the content of the particular file, and metadata is all about the source from where we read the document rather. Okay. Now, so it is a list of document. Okay. And if you really interested to see the type, as you see, as I told you that document is a class, one of the class present on the LangChain core documentation like this. Okay. So it is a list of document. Now we need to convert it to a list of string. Why we need it? Why not we keep the list of document? You will understand when we come across this section. Just to brief you, when we want to insert content into the BigQuery as a vector data, vector data over the table, it expects a parameter of list of string, not list of document. That is why a conversion is done over here, so that we can push this content in the vector database of the BigQuery. Now let us convert. It's a simple Python 2 lines, and it will convert the LST document to the LST string content. So I abstracted the content from here. Now this is our source. We are going to, so that means that our app read the data from the particular GCP bucket and had it over as a list of string. Now we want to work with the BigQuery over here. Okay, so this is our target for today as a vector database. We choose BigQuery. Now what we are going to do is that we need to again install couple of libraries over here. Okay, one is LangChain Google Vertex AI for the embedding purposes, and one is our Google Cloud BigQuery. Okay, just remember any library that is coming across the flavor of LangChain, it is just appended with the sign of LangChain. And this particular library, Google Cloud BigQuery, it is not related to LangChain. Okay, it is a Python library that is needed to work with the Google infrastructure. So as this particular library also. Okay, now let us run this particular command to install this required libs over here. Done. Now you have to, when you want to create, let's say let me bring up the Google also over here. So this is our BigQuery. Okay, now that we are going to create a data set over here, under that there will be a data table that will actually hold our vector data, right? So for this particular activity, if you want to create this thing from running this Python notebook, then you need to populate few property over here. One is your target project ID of the GCP project. For me, this is my ID. Okay, the region where you want to create it, I want to create it on Asia South 1. Name of the data set, give it vector data set, and table where you want to store the data. So as I am working with light, as I told you that I have put it the table name as TBL light. So this configuration is needed. Now I have commented this particular line, and if you are not sure that your target, what is your target environment project ID, so you can run this particular line to set the gcloud configuration file to a particular project ID. So how to set this up, what is a gcloud console, what is the objective of this, so we can talk detail in a separate video when we discuss with only on the Google Cloud infrastructure. So that is not the objective of today. Now we come over here, so let me run this line also. Sorry, yep. Now we come over here. As I told you that vector in this particular Vertex AI will be needed to create the embedding. And if you remember my previous video, embedding is that we are pushing a textual content to the vector database, and vector database is nothing but a numerical representation of a vector to an infinite space. So our text needed to have some kind of embedding so that the text can be converted into the numerical vector data and can push it back to the vector database. So that is what is embedding all about. So let us create our embedding first. So for the embedding, we need one kind of model that is responsible to do the embedding. For Google infrastructure, I am using this particular model. Okay, now let us create the embedding. Done. The embedding has been created for us. Now what next? So obviously we get our data into the app. We created our embedding also over here. Now we want to create our BigQuery dataset and data table. So for that, I am importing one particular lib over here. So, and this is the Google Cloud. Again, this is not from LangChain. Again, I am repeating to you, this is not related to LangChain at all. This is a standard Google package, Google Python package that is available as a Python library, so that Python developer can connect to the Google Cloud and work on it. So from Google Cloud, I am importing the BigQuery because we are working on the BigQuery right now. So for this particular BigQuery, to create the BigQuery client, it expects some kind of parameters. Its project, your credential, HTTP location, those kind of thing over here. But I have already set my credential via service account while I set up this particular Notepad environment. So I do not need to pass any kind of credential right now, but if you have not set it up, you need to pass a credential over here. And the best practice will be create a service principal, download the JSON file to your hard disk and refer to it. So we are putting the project ID over here and the region and the name of the dataset exists. Okay, so it will override if it is existing. For now it is not existing, so let's run it. So what exactly we are going to create? We are going to create a data set in the BigQuery over here. As you see here, no data set is present at all still now. So let's run it. Okay, so we have created our vector dataset. As you see, our dataset is vector underscore dataset. Let's see in the Google portal whether it has been created successfully or not. Okay, let's see. Let's refresh this. Let's open it up. Yeah, here is our dataset. So this dataset does not have any kind of data table associated with it. Okay, so this is our vector dataset, and now we are going to create a table and store our vector data over there. Let's come back to our original workflow. Come over here. Now we are leveraging this particular library, LangChain Community Vector Store. We are exploring or importing the BigQuery vector search over here and the distance strategy. So now for this particular demo purpose, we are using the Euclidean distance. Sorry. So here is a very simple code. So we are passing in this particular constructor, we are passing the project ID, the dataset means where we want to create our table over here, the table name and the region and the embedding and the distance strategy. For this purpose we are using the Euclidean distance. Okay, so let us run this particular code. It will create a table under this particular data set that we have already created. If you remember that I've shown you over here. So the data set is created, it's called vector underscore dataset. So let's quickly run it. So actually what is happening, it is creating a blank table right now. Okay, so let's see. Again, coming to the Google portal, let us refresh this one, see the end result. Oh, sorry, let us open this up. Sorry. Okay, I clicked somewhere else actually. Anyway, so this is our vector dataset, as you say, and this is our table. Right now it does not have any kind of data. Okay, now it has some ID over here. As we created the vector database, it has a in a column ID, document ID, metadata, content, and test segmenting. Okay. Now, if you go over here, to preview the data, you will see that it does not contain any kind of data over here. If you go to the detail, this is the detail. Number of row is 0 actually, because we have not pushed the data yet. Okay, and it is created on Asia South location that we put, opted for in our code base. So now let us do one thing. Let us push the data. So as you remember, when we work on this particular LST content, okay, so it's a list of string. So obviously every list of string has some number, means how many characters are there, right? Lane of that. So I'm just taking the lane of that as a metadata. It is not essential. I'm just creating some kind of metadata for my for my string that I want to push in the vector database. It is completely optional. You can skip the metadata part, or you can put more information into the metadata depending upon your business cases. Now here, as the store has been created over here, okay, only the thing is that we need to call this particular method. As I told you, if you see this particular method, just see the signature of the method. It says that it is taking the text as a first argument, and that is the list of string, okay, and metadata as list of dictionary. Now that is what in the previous step we have converted. If you remember, we get the data from GCP bucket, and that was a list of document, okay, and we converted the list of document to list of string only for this particular reason, because this particular database, when we explore this add text method, it accepts a parameter, the first parameter text, as a list of string, not the list of document. So there is a significant difference in this particular vector database. One thing I may forget to mention you that whatever use case we are dealing with, it's a part of a larger project that we are going to handle in the future, and the same project will be rolling out for the Google Cloud as well as the Azure Cloud also, with the help of the Azure OpenAI search. And there you will see that you don't need this kind of conversion from list of document to list of string, because it accepts as a parameter of list of document, not list of string. Okay, so here is a difference between them. Just put it as a side note. That's it. Now we are going to add this particular add text, call the add text method, push the list of string with the metadata that we have created. And again, I'm telling you, this metadata is optional. You may want to give it, you don't have to give it also. If you don't require, don't give it over here. Okay, so let's run it. Well, so you see that all the data, our embedded data, is pushed to this particular vector store. Okay, now let's see. As you remember, in the detail section the row count was 0. Now let us refresh it. Now let us open this one, our TBL Lite. Now go to the detail section. See, we have 7 rows right now. Okay, so 7 rows has been inserted to this particular vector database. Okay, and if you preview the data, previously it was blank, right? Now you see you have the content over here. This is the content, and this is the embedding, the same representation of this text to the vector database. As I told you, it's a numerical values, is a vector space, okay, vector coordinates. Very hard to read actually for human being. It is impossible to read actually, frankly. Okay, so you will have the 7 document over here. Okay, so we have successfully inserted. This is the content, and this is the vector representation of it, and the lane is 645. Now let's see, a lane is as we created the metadata and print it out. If you remember that our first document or list of string is containing the character, the lane was 645, and so forth. For lane 2 it's 1609, and at the last is 2686. Okay, Now let us query. The final objective is, so we have created the BigQuery. Okay, over here we have created our dataset. We have pushed our vector data to the TBL right over here. Now we want to fire a query and get the result back from this particular vector database. So let's do it. So here is a variable query. You can put it, let's say all the document, let's say, we are searching for a word called Maxwell. Okay. Now let's run it. Okay, this is our query. Now what exactly we are doing over here, we have two methods to do the same thing, but there is a significant difference between them. Okay, the difference is that, see, in this particular first method we are calling the store.similarity search. Okay, and in the query it accepts the query as a string. Okay, so if you are writing a simple query, if you are not doing the embedding of the query, okay, because in the vector database our text is stored as an embedded and stored in the vector database. Okay, so obviously our query also need the same kind of embedding to find the Euclidean nearest search between them. Okay, so but if you want to skip the embedding part for the query at least, so you will be using the similarity search, and behind the screen it will automatically take the query as a normal text format and it will perform the embedding, then it will go for the actual vector search. Okay, and this method is useful when you already had a vector representation of your query data. Okay, so it will not do another vector over there, and it will just take the search vector and do the semantical search in the vector database. That's the difference between them. Now let us first run this one. So to give you a nice view what is happening over here, I am taking the return val over here, printing the return val, but in a small window it is impossible to view what is happening over here. That is why I am creating a JSON file also and dump it to the hard disk, so that I can open the JSON file and show to you what is the content is all about. Okay, and what we are actually returning back. So let's run this thing first. And this file, as you see, as I told you, in a small window it is impossible to see. It has a document, it has a content. Okay, and in this way it will be a little difficult to see. In the metadata it has a length also. So what I am doing over here, that I am abstracting the metadata and page content and taking it as a JSON output and pushing it to the dosearch.json file. Okay, I am doing the same activity over here, but for this the file name will be the vectorsearch.json. Okay, so I will run in parallel. Let's run this thing also. Okay, so we have two JSON representation. Now what we get written from the actual vector search. So this is the dosearch.json. So see, it is finding the keyword Maxwell. So it is finding the keyword in this particular page content where the length is this one. Okay, and job ID is a BigQuery job that the BigQuery has run to perform this kind of activity. So it has written us 1 2 3 4 0 1 2 3 4. Ideally it's the 4 nodes that it has returned to us to find the word Maxwell. Okay, now in the second tab we have the vector search result. Okay, so as expected that should be similar in nature also. So it should be returning back to us those 4 results, and successfully it has returned back the 4 result. So either way, if you execute this method or this method, the end result will be same to you. Clear? Now let us explore another word. Okay, let's guess SNBOS. Let's see what it is going to return to us. Okay, it found Satyendranath Bose, SNBOS. Okay, and let's try this one also. Yeah, it also found the same thing. Now if I move back to the JSON file, so this is my doc search result. As you see, this is the keyword it is looking for, Shotananath Bose, SN Bose. So I search for SN Bose. Okay, it has returned me this particular 3 document from my document library. Okay, same here. If I refresh this out, as you see, it is the same result, and it returned back the page content over here, and this is the metadata that we have pushed with this particular chunk of data, the lane of the data. Okay, so we have successfully created our vector database, this one, and we have successfully pushed our embedded data to this particular vector database table, and we can now perform the search activity and get the RAG search back to us. Okay, this is the RAG output, read file 1 and read file 2. It's a list of document. If you touch it, you will see that it is a list of document that is returning back. Now today we talked about this. In the next upcoming video, I will take this RAG output, means when we do perform this RAG search, okay, over here it is returning back as the list of document. So that is the list of, you see, document is one of the class in LangChain. Okay, so it is returning us the list of document. Okay, now what we will do in the next step, in the next video, that we will take this list of document, I mean this red val, okay, and we'll push to this LLM, large language model, Google Gemini, and we'll get summarization. Means, as you see, this is a huge text chunks, right? It's a chunks of data. 4 chunks are there. Page content, as you see. Okay, now we'll push this data to the LLM and take away the summarization and give it back to the user along with this RAG search result. That is the end objective. So we'll be discussing more on the second video, how to integrate and pass this particular RAG information to the LLM and get it back from the LLM. There are few interesting things, because at that point we will be exploring the runnable interface of LangChain. What is runnable we'll discuss, and we'll be creating our chain, our agent, to perform this particular activity. Okay, connecting to the LLM, get it back from the LLM. I hope you have enjoyed this video until now. So we'll be meeting in the next video, and as previously, as I have told you in all my videos, if you like this particular video, so just give it a thumbs up, give it a like, do share as much as possible for you, and subscribe to my YouTube channel. Thanks, friend.